Welcome to the Gotham Sound Everything Over Fiber for production and events and, home audio, theater, whatever you want to do. Thanks for being here today. Thanks for watching online. I am joined by Marcus from Wisycom /DPA and Lukas from TecNec. Both of these guys have been instrumental in my personal learning of how the heck all this stuff works. So without further ado, I'm going to turn it over to Marcus, who's got a couple of slides to go through. So Marcus, why don't you take it away?
How you doing, everybody? Today, I more wanted to explore the simplicity and the use and the building blocks of Wisycom's RF over fiber, and then some of the products and technologies that we have. We based the scenarios around a sound location cart that everybody's familiar with. You have a cart, you have your diversity antennas, and now production, now you have to kind of cover a house that's pretty much exceeding the range of traditional coax cable. And in many cases, we humped coax. That's the way we did it. We kind of put it together. But now we're dealing with the physics of the loss of those coax, and now we basically have to start engineering to kind of make up and overcome for that loss to not affect our signal to noise in those scenarios. So Wisycom has a couple of single channel fiber optics where we're converting coax into the optical, sending it over light, and then converting it back to coax on the remote side. And this here is pretty much a single channel, box. And the nice thing about coax, people say, why go fiber? And one of the benefits is now we can make those runs without the inherent loss that we have in traditional coax, cable. The link budget in the optical boxes is roughly about 20 kilometers. We use a 4 milliwatt laser. So at the operating ranges of production, a lot of times we need to go a couple of thousand feet to kind of cover a house, a stadium, either from the location cart or from master control or video village. So now we have tools to kind of, plug and play. So any application that you would traditionally extend, in this example, I have an omni paddle antenna, but it can be a shark fin. It can be kind of whatever you normally carry in your bag. Now you can extend that diversity set of antennas. And those are going to be some of the examples and some of the building blocks that I kind of show in the next couple of slides in terms of how do we accomplish that.
While you're doing that, one of the projects that we all worked on together was something for Daytona Speedway, where they had 3.2 miles of fiber run, and we were running Wisycom antennas and video and audio and comms all through that fiber. And so, if you were to do that with coax, I don't even know what the makeup gain would be. I believe it would be impossible.
Yeah.
Yeah, 3.2 miles a long way.
Yeah. So these are the single fiber boxes, and all of the boxes come in pairs. So there's going to be a transmit side that normally in a microphone diversity receive lives on the remote side, because we basically want to pick up that microphone and then send it back to our receiver. And then either at your cart or at your master control, you'll have the receiver that'll basically then take it from the optical domain back to coax, and that's what goes into the A or the B port of your receiver.
And just one other feature about these is that they have, we talk a lot about filtering in RF and how that, that even as we get more and more wideband with the receivers, it's more and more important to have a filter built in to kind of prevent RF overload with the receivers. And these have filters built in and remote control and all sorts of good stuff to do that.
I have another slide a little down, but since we hit on it, we have filters. So the optical boxes will cover pretty much almost the full spectrum of products that we see in the industry. So they'll start at VHF from 170 and go all the way up to the 1160 range. We don't utilize that upper part of the range here. I think here in the US, we top off right at around 960. And we have different filter sets. We have a VHF filter, a 960 filter, and then we have various high-low and high-pass band filters, on the unit. And but one of the best filters, the one that I like and I recommend to a lot of people, is we have a 40 meg floating filter. So once you kind of set up your coordination, Most of the antennas in the industry pretty much will pick up everything that's coming on into the air, and a lot of them are very efficient, but what we want to try to do is kind of narrow how much information is coming into that antenna that we're basically going to send to our receivers so they can do a good job. And that's where a lot of the filter sets kind of come in. And the fact that we can move that 40 meg filter up and down the UHF spectrum, once you have your coordination, you can kind of dial it in, protect your mics, and it'll block out all the noise you don't want to see.
Are those filters built in to the unit, or are they plug-in?
The filters are built into the unit. So yeah, you're going to have them on all of the fiber boxes.
And one other thing, just to expand upon that. So it's not just that this can be, like the transmitter can be at a receive antenna and then transmit it back to the cart. It can also be the other way. So if you want to have your IFB signal sent over fiber, you can output the RF from your IFB antenna with a couple of caveats into the transmitter, go over fiber out to the receiver, and then have that de-squeezed into a transmit antenna. So you can do both ways, transmit and receive antennas, both going over fiber bidirectionally.
In this example, we basically have local antennas pretty much at our receiver, and in this example, we're using Wisycom receivers. But that can be whatever RF receiver you're currently working with. In the RF domain, RF is RF. And now we're coming out of the Wisycom, the secondary outputs on these units, which is the second zone, and now we're going optically to a secondary zone. And for diversity, we would need two of these single channel boxes, one that will bring our A side, and the second one will bring our B antenna, so we maintain diversity in on our second zone. The other feature that we have built into these boxes is we have the ability to bias power if we're utilizing smart antennas, active antennas, or powered antennas. So it'll provide the bias to kind of get those working. So we have a lot of tools built into this unit besides the filtering and bias power. We also have attenuation. Because we're basically bringing these signals back with no loss, a lot of times we run into the opposite issue. There's too much RF signal kind of coming back. So you start looking at your meters on your receiver and you see that your A and B signals are kind of pegged, and you may think, oh, that's good, but it's actually not. So we want the diversity working, fluctuating between our A and B antennas, so we have a 6 dB attenuation pad built into the units where we can kind of bring that level down. And once again, it's just, we're trying to think of all the tools that you're going to need on site to be able to adapt to those environments.
So something that Andrew from Deity mentioned to me is that, I had always thought that 100% RF level was the best RF level. And, what you just mentioned is that 100% is maybe not great because you could be oversaturating, overloaded, and that having it in that like 60 to 70% range, a lot of time, like how you would expect your audio meters to be if you were recording appropriately, where you've got a little bit of room to go up, you've got a little bit of room to go down, but that 60, 70% of an RF meter is going to be just right.
Yeah.
Just enough for the walkies to hit.
That's right, yes, just enough for the And another reason for filtering, right,
Yeah.
is, to get out that 470 range.
Yeah.
So this one right here, that brings down the level? Those cursors on the box? Does the same thing as the rack mount? As the rack that you had?
Yeah, so
Yes.
that can lower the input gain
Yeah.
on the box,
Yeah.
yep. And adjust the filters and all sorts of things in a menu-driven way.
Yeah. Yeah, all of these units have a small GUI, on them, and yeah, the up and down are just to be able to turn the different sections of the GUI on and off depending on what section you're in.
And an app too, right?
And then also the Bluetooth app.
Bluetooth app for your phone.
Yeah. In January of this year at the NAMM show, we introduced our 2-channel fiber optic, converter, and we built in, more features. One of the things that the market was asking for is control. We offer control via the Bluetooth app, but on some of the larger setups, being able to control it over an Ethernet or some type of network path back, to the unit, especially if you have multiple sites and multiple zones coming up, is preferred, and we've been able to incorporate all of that in this unit. So some of the connections that we have here is now we have 2 optical converters for RFA and RFB on the units, and that'll convert it optically on our diversity for A and B on the one device. We also have an SFP built into the unit, and that's where our control kind of comes back. Now, our fiber connections are SC-APC, and I'll defer a little later for Lukas to kind of get into some of the different connectors on fiber, but all of the Wisycom boxes are SC-APC, but the SFP is an LC connection.
Is that also APC or is that UPC?
I'll need to find
Okay.
out.
It's blue, so it's going to be UPC.
Aha, we'll get into the difference between that in a little bit, but
Yeah.
suffice it to say, much like you've got XLRs and BNCs, there's a whole new terminology to use to learn with fiber to make sure that you get it just right, because it's light, and if some of it is angled and some of it is not angled, if you're plugging angled into not angled, it's just not going to work. So it's important to know that you have the right connector, the right angle, the right polish, all of those things.
Yeah, we continue to have Bluetooth control on Wizy Bluetooth app to be able to dial into the unit. And then we also have 2 Ethernet connections. So on the SFP, that'll be a separate fiber strand going back on this particular model. But now you can extend back, it's a bidirectional SFP, so now you can extend back 8 gigabit network connection at your remote site. So it's another feature, it's another tool when you're in a remote world in terms of how you're gonna deal with kind of production needs and challenges in the most efficient manner.
And so just to think about like the possibilities of that from a production standpoint, right? So that's just Ethernet, right? So with Ethernet, we do a lot of stuff with Dante, like that can give you a really, really, really long Dante run in addition to your RF over fiber. It can also give you, with the Clearcom transceivers over IP, you can plug it directly into there, and all of a sudden you've got 10 channels of remote comms. So there's a lot of things that you can do over Ethernet, just piggybacking onto this box, that make it really, really useful. I mean, we talk about like everything over fiber, like you can do everything over the internet, like that's part of everything.
Can I ask with that EFL2, how many strands of fiber, is it 2 or 1 that go into that?
This particular unit, we're utilizing 2 strands of fiber for our RF connections. And then to do control, that would be a 3rd strand, and that would be through the LC connector.
And the 3rd strand is a bidirectional strand, and that's done with muxing, which we may talk about later, I don't know.
In the same example here, in the prior slide, we were using single channel boxes to extend our zone. Now we can do 2 coax in and 2 fiber runs out to our remote site, but now we're managing that on the one device. Now this box is available in multiple flavors. This particular unit has separate opticals conversions, but it's also available with a 2-channel mux. So it would be 2 RF, A and B, being combined or muxed internally down to a single strand of fiber. So on those, you'd have 1 connection. And for certain production leads, that may make more sense, because if you want to do control, then that'll utilize a 2nd strand of fiber.
Can one of you just quickly explain what muxing means?
Multiplexing, simply, it's using mirrors to refract light, essentially, so that you can get splitting the wavelengths of the fiber and basically send what would be 1 signal per strand down, multiple strands down 1 strand, basically. It's a very non-technical explanation, but it can be done. Wave division multiplexing is what it's known as. It's 2 into 1 or 4 into 1.
I think
Sure.
the way Peter explained it to me was that you basically are changing the color slightly of each of the signal paths.
Yep.
So, red and blue, let's say, even though we're dealing with much different color light levels.
So right now, with that unit in your hand, you've got a free, it could be feeding another antenna under that vacant coax, right?
Yes, this is a 2-channel box.
Yeah,
Um,
for this example, for the table, I just have just one leg, so we just have one half of the diversity set up in the example. But in the real world, yeah, you'd have your A and B deployed, so 2 antennas, 2 coax cables in, and depending on the box, either 2 fibers out or 1 muxed fiber. We had touched earlier in terms of our 40 meg, floating filter.
Oh, it slides.
Yes.
Fancy.
Thank you.
And that's it, everybody. That was the grand finale.
I had to go to YouTube for that one. No. There are a lot of filters on the market, but most of the filters do not cover the entire UHF range. So when you go to mini circuits, some of them are fixed, filters that you kind of put in line, or you go to your toolbox and you take out the next filter that covers the next range. The fact that it's variable or tunable gives you the flexibility after you establish your band plan and your frequency coordination on where you want to optimize that filter to kind of block out everything you don't want. And in scenarios where you're utilizing a mix of wireless gear on site, so everything doesn't fit in a 40 meg window, that's when then we have the high pass and low pass filters that are kind of built in. Our low pass is going to only allow low frequencies once you set a start point to kind of come into the unit, depending on the band plan that you have set. And our high pass does the opposite. It basically only allows our high frequencies above a certain point come into the unit. And these are just tools that allow the receivers to kind of discern the information they need to do a good job.
So like what you said earlier, Steve, and I know you just raised your hand, but about, walkies hammering you, that high pass filter, if you can get that up in around 500 or 490, that can really help prevent walkie damage.
Can you double filter the antenna and that fiber unit?
Great question, and yes, you can. So yeah, you can utilize the filters in the unit, and when you're utilizing smart antennas that also have filtering, you could create a double wall situation for the max protection, especially in just very dense or very bad RF environments where the noise floor is and you want the most protection you can. Sometimes on location, you only have room for one take. So these are, once again, tools that are going to buy you peace of mind.
Aside from the distance, the capability of running 3.7 miles, what's the benefit of fiber over Ethernet? Fiber is expensive and precise and really susceptible to dirt. Ethernet is sort of readily available, affordable, and there's a lot more.
There is loss because it's copper. There is loss with standard Ethernet, like and Peter, you can nod your head if I'm getting this right, but I believe it's 300 meters.
300
or is
feet.
it 300 feet?
300 feet.
There you go.
Yeah, 100 meters.
Feet. Yeah, for a standard Ethernet cable, just copper. So you start to experience loss, and then bits drop, and then you either have to put it through a switch to reinvigorate it and send it on down the line, or you just start losing stuff. So with fiber, the light, as long as it's managed properly, is close to lossless.
It's also lighter weight. That's the other thing. I mean, distance, you said outside of distance, so I guess that doesn't count anymore. But it's lighter weight and also higher density. This is 4 strands. This could be 4 networks. This could be more than 4 networks if it needed to be. But imagine a big old spool of coax. It would be a lot bigger than this. This is 500 feet of fiber right here, 4 strands of it. 1,000 feet wouldn't be a whole lot larger either.
Right. You think about those old mult boxes that have like 16 channels and they only go a couple hundred feet and they're like 75 pounds or 100 pounds, running that. Whereas like a 16 channel fiber reel would not look that much different from what you see in front of you in terms of the actual, because it's so thin and so small. And that's, in terms of the Daytona project, that's the kind of spool we were using to send multiple channels of audio, RF, video, comms, Ethernet, all that stuff. It's just one strand, one run.
Yeah, when it comes to RF, my understanding is you're limited on Ethernet regarding, and to move RF, there's not really any practical solutions to be able to do it that way. On the communication side, for satellite communications and phones, it's a mode of transport. In audio, we use it mainly to kind of move Dante once we're converting, to move audio after it's been converted in a digital realm. But for RF, we're using, fiber and coax are pretty much kind of the two standards in our industry. And it also gives us the ability to move other sources, such as folks that are dealing with microwave cameras. It's very complicated to be able to extend a signal, especially if you're in a stadium, when you're dealing with cameras, 4-way and 8-way camera systems that are operating 5 gig, 6 gig, and 7 gig. So what is normally done is there's a blockdown that will convert that frequency below 1 gig. And now we can extend that with no loss from that lockdown point back to the receiver. And now we can use a product like the BFL2, the Wisycom fiber converter, as an option to be able to bring those receivers or those signals back to our microwave receivers.
Just to piggyback on that, one other reason to do this, the bandwidth of fiber is much greater. You said cat cable. What kind of cat cable are we talking about, I guess? I mean,
6 or 7.
sure, yeah, but so those are the most expensive ones at that point. We're already talking about that. We're already at that point limited to 300 feet. This can handle 10 gigs per strand, no problem. And additionally, to the point of video and other types of signals, I mean, this is a multi-strand tack reel. You might be sending video over it. SDI over fiber is just as much of a thing as RF over fiber for the same reasons. So it's got more potential uses than an RF cable, which is that and nothing else. So, yeah.
Just to go back to the video part, one thing that I was really amazed about, and Marcus touched on this, but the new, the wireless video receivers, they have multiple antennas on them, and the way that that they're using them in this instance to provide coverage all around, the Daytona track, was to do RF over fiber for all 8 antennas. All 8 antennas were being down converted to be in that, they were actually doing it in 700 megahertz, because that was where he thought was the cleanest. So they were being down converted from 5.2 down to that, and then the receiver was receiving it at 700. So it has an offset built in the receiver to plan for this. And the reason being, right, we all know that, like, if we've ever tried to use like a control network, like a 2.4 gigahertz antenna, 2.4 just doesn't carry well because it's so high on the frequency, and there's a lot of loss through coax. So they bring it down to get rid of that loss, to get rid of that loss over the coax into the fiber and then back. And that really is a pretty, it's a neat, it seemed like magic at the time.
Well, just one quick question about the cable.
Sure.
Do you have to be really precious with it, or
Yes.
like you do, right? Like,
So-
you need to like, take care and hang it.
We'll get
so
there.
people
Yeah.
walking on it, and it's very fragile.
So
It's when they grab it and yank on it.
Yeah.
The cable itself is quite durable, the ends are not. Fiber cable is very inexpensive, ends are not inexpensive.
Ends.
Putting them on in a way that makes them good enough for production is not really doable in the field, no matter what the manufacturers say. If you don't have a guy with a fusion splicer walking around, you're gonna have problems. You're gonna be cleaning that thing all the time. The troubleshooting techniques are different. People have to be taught how to do it, because it is a binary thing. It either works or it doesn't. There's no, it's a little crack, let me just wiggle the thing. Either you've got light there or you don't.
yeah, and we'll get into that, but just to repeat the question, and then Lucas, if you can summarize.
Sure.
Kind of, because you told me the same thing earlier. The question was, how fragile is the cable?
Yeah.
And Lucas, you can just summarize that.
Yeah, I mean, people that are new to this are usually a bit nervous about it for that reason, because there are fragility issues or cleaning issues or considerations like that that you just don't have with copper cable. That's correct. Like you said over there, the cable itself is incredibly durable. This is tactical cable. It's crush proof. You can run it over with a car. Nothing will happen to it. The ends, not so much. They need to be treated with care. There are dust caps. There are a few basic things that you need to do with regularity to just keep this in good working order, and it will be fine. That said, there are a lot of different flavors of fiber for field use. This is one of them. It's not the most reliable. These connectors are, like, there is a fiber right inside that ferrule. Its tip is right out there. I could make this unusable just by rubbing my finger all over it. I could also clean it in 2 seconds after doing that, and it would be fine. But, you know, depending on who's actually going to be using this, running it, plugging it in, etc., there are different styles. This is nitric optical con. It's foolproof. It's great. It's IP rated in its closed condition, as are the chassis mounts it mates with, unless they're mated with this connector. We can talk more about this later, or maybe over at the booth. And there's another video I think we did that we'll cover a bit of this as well. But there is a solution that is bulletproof if it needs to be. And there's more than just this as well.
Yeah.
So you're talking about standard beam connectors. Show me any product anywhere that anybody can buy if you're not
I'm not
a
talking.
government organization that uses those.
Yeah.
I mean, so number one, you know, the answer is to have multiple adapters, right? Would be to use that and have adapters. But then, like we first kind of got into RF over fiber with a company called BSRF, and they do have optical con built into their chassis.
Yeah.
So it does exist, and you know, if you plan around it, it's all about planning, right? But you're 100% right. Like those ST connectors, yeah, they are fragile and on set. They could be a liability. But that's why when we sell stuff, we sell the optical con technology with adapters, and we always recommend multiple adapters.
Yeah.
You know, when it's all brand new, it's all great. What happens 6 months later or 9 months later in the pouring rain with the new guy that you have run the cable
Sure.
out, you don't know what's going to happen.
Yeah, I mean, you know,
You can
but
break anything if you
the
want.
new guy will break anything. You know, I think that's you know, they'll break the fiber, they'll break you know, they'll rip the B and C off the end of the, you know, the coax. Like, you know, that's the new guy. So, you know, yeah.
I do think Dave's point too, like, I've been getting fiber cable off of Amazon for stuff that I don't care about, where it's, you know, the ends are gonna stay until I'm done with the job and I don't intend to reuse it.
Yeah.
For jobs that he doesn't, you know, where it's just going to stay stationary, where it's not going to move and it's just going to be in there, like the Amazon fiber cable or like a fiber cable that you'd get online is more than fine. You know, for the jobs where things are going to move, where they're going to plug and unplug and all that stuff, that's where you want to make the investments for durability.
Yeah, and like the more than, I would say it's like when I can afford to take my chances.
Right. Okay. Yeah.
Which is a different
Sure.
than professional.
Yeah. Yeah. So yeah, the idea being when you can afford to take your chances, you know, you can cheap out on it. But when you can't, when it's mission critical, that's when you go with the more bulletproof solutions. Anyway, want to continue?
Yeah, so we also have, these boxes can be used in either 2 modes. They are bidirectional. So we've been talking about extending our receive antennas. And that mode is called antenna mode, both in the single channel and the dual channel boxes. We also have a mode called IFB mode, where now we're basically want to extend our IEM signal and send it, and that can be either a utility listen or IFB or just a long-range camera hop from Video Village out to location that can be several thousand feet away. So now we have great utilization, some great tools where now we can kind of use our RF over fiber boxes to now send our IFB signal back the other way. And what happens is the position of the boxes then just switches. So now our T box lives on your cart because we're coming out of the IFB into the T, and now we're sending it out into the remote unit that's going to be the R version of this. And that's, will basically broadcast that signal out to your IFB packs out in the field. And in order to be able to do that, because we cannot send power over the fiber, so we basically have to send a 0 dBm reference signal over the fiber. So we have to either, in the Wizy world, we already have a 0 dBm BNC SMA connector on our transmitters. But if you're using any of the other industry transmitters, then you can reach out to the engineering team at Gotham or call us at Wisycom, and we'll give you what the pad values are so you can kind of get that signal down. And once we're at 0 dBm, now you can properly send it over the fiber. We go back from optical to coax, and that's when we introduce an inline amplifier. All of the Wisy boxes in IFB mode now have the ability to now bias power this amplifier to kind of bring our signal now right back up to a clean 100 milliwatts on the remote world for your IFBs. And we can do this for equipment in VHF range, which there's a lot of in this industry, or any of the brands of UHF IFB products. So we're trying to give you a lot of tools to be able to be very adaptable, but also the best utilization in the same gear where you're not buying gear that's can only do microceive or IFB. You can adapt to what your needs are on site and on location. So here we're using a Wisycom transmitter. And we're showing same thing. We can move those signals optically on a single channel device. And the antenna that we're featuring here is a shark fin antenna, but it's designed for transmit, so it has this amplifier built into the antenna.
Is there a different transmit shark fin antenna that Wisycom offers than the standard LFA, or is it the same?
The antenna is called the LPB, Larry Boy Paul. And it's a shark fin with a built-in amplifier that's strictly only for transmit only. And really the application is for retransmit of fiber because it's providing two functions. It's basically bringing up our signal from 0 dBm back to a plus 20, which will get us back up to about 100 milliwatts.
So Jared, if you're listening, we should mark that as a new product that we need to know about because that's news to me.
And yeah, here we have the antenna, the LPB, and this amplifier that's available in two flavors. We have a VHF amplifier that'll basically bring up our frequencies in the VHF realm between 170 and 220.
That would work with Comtex.
And then we make a UHF version, between 470 and 700.
You use that amplifier on the Wisycom antenna shark fin that I have. Do you essentially make an LDP transmitter, or is there something else other than just the trend? Is it wired differently?
No, if you already have Wisycom antennas, let's just say passive antennas, passive shark fins.
Well, active shark, they have attenuators.
You could not use active antennas, as those were strictly designed for receive, and yeah, you can potentially blow them up. Yeah, yeah.
If you're not using the transmit or using the receive, like that antenna there, I see that has power. That unit will power that. You can use it, you wouldn't put any gain on it, but you could use the filters on it, on this one here, as a receive.
In a receive application, yes, you can use this antenna, and we can bias power receive active antennas. But when we're talking transmit, this amplifier is designed to kind of work with either your passive paddles or passive shark fins, and you can kind of put this in line just for the means of bringing up our signal, because there are a lot of people who already own existing paddles, so you can use that in line, and yeah, you'll come coax from your fiber unit into the amplifier, then from the amplifier into your antenna of choice.
One thing I want to point out is that these are expensive boxes, and on set, like, you also don't want to have these hanging around. So what a lot of people are doing is they're making little boxes for their fiber converters, like this one. This is something that Peter made, and I think he said it's like 90% Amazon stuff. And this is not for RF over fiber, but this is for Ethernet over fiber. And so you see there's a fiber connector here. There is a V-mount plate for a battery or a DC input, and then you've got your output for your actual Ethernet for your comm antenna. And then inside, it's a very simple, it's really just connectors to the fiber converter for both power and I/O. So we're seeing, people with larger Pelican cases and different power solutions with either, batteries inside or outside, with their Wisycom fiber to be able to put like an optical con on the outside and then breaking it out, keeping the more fragile connectors safe.
Is it single mode cable compatible only?
It's, yes, single mode only.
So theoretically, you could use your smoke conditioning cable if you had to use somebody's multi-mode plant because there was nothing else available where you were.
It's not designed for multimode at all, and some of the tests that have been done were other folks. It just doesn't work well, so it's not something that the factory recommends.
Sorry, one follow-up question on the transmit RF amplifier side. How many carriers can we get?
This amplifier is designed for a single carrier, so one frequency. There are methods to be able to do 2 frequencies over the amplifier, but it involves some other stuff. And I'd say reach out to your folks at Gotham or the factory, and we'll discuss your application and kind of give you the right values. But for off the shelf, it's designed as a single carrier amplifier.
Thank you.
Yeah, thank you.
So that brings us to kind of the integration part of it, right? So Marcus, that was brilliant. RF over fiber, Ethernet over fiber, and Lucas is doing a lot more of the fiber stuff, and you have your own presentation. Is that
Sure, yeah.
correct? So Lucas, why fiber?
Yeah, well, we touched on a lot of it already, but this is a good summary. It's lighter weight. It's 80 to 90% lighter weight than copper. You can have a lot of redundancy. You can have a lot of channels for a lot of other things than just RF. You might need a network for comms. You might need a network for Dante. You might need multiple strands of SDI or anything else. You can do that with this. It's not only got one use like an RF cable does. The distance, obviously, we've already talked about that. That's why this product exists, it seems. And it's real. 24 miles. Pretty insane. These are both single mode products. We build single mode and multi-mode assemblies. Single mode is what you're going to encounter most of the time. And if you were investing in this yourself, that's the way to go, just because of the longer distance that it can accommodate and the higher bandwidth. But
Can you
that
just touch on
question.
the difference between single mode and multi-mode?
A little bit, yeah. The wavelength that and the way that light actually refracts up and down the strand is just different in its construction, and the diameter of the fiber itself is different between the two. That is not a very technical explanation. The decision to use one or the other is going to be determined by your equipment. If you're buying Wisycom equipment, you need to have single mode fiber. If you're doing long distance broadcast related things, it's going to be single mode fiber anyways. Multi-mode is older. It had more network applications, and it's just not really being built into new technology very often. Single mode is superior, and that's why people use it. You can multiplex through it in ways that you can't through multi-mode as well, although that sounds kind of counterintuitive. It's a newer technology, and it's superior.
There was one thing on there that was interesting to me, that it said immune to electromagnetic interference.
Yeah, I mean, that's why we're doing this, right?
Yep.
Yeah, you can put it right next to power, and it won't mess with it at all. And that's why the Wisycom product works so well, is because it's RF. So yeah, another benefit there.
Here it
Color
is.
codes. Those color codes that you're seeing there, the top several of them, OM 1 through 5, those are different types of multi-mode fiber. OM3 is the most common, but those color codes really just refer to patch cables. What we've got here, these are field assemblies for deployment on site. They're black. They're yellow here, but they're black. Most field cables are going to be a shiny black tactical jacket, and that's what they are. If you need to know, that's how you would, but it's not too common. There's a lot of different connector types as well. I've been saying all day that I wanted to avoid alphabet soup to you guys here, and I'll do my best to, but really, it just comes down to giving Gotham a call and asking them what you need.
And then I can call Lukas and he can explain it to me.
Yeah, but
Which is how it happened, just to be clear.
yeah, but like I was saying, there are different styles for different applications. The top three on this slide are all like this. They're relatively fragile. They're physical contact, meaning the fibers themselves are nearly touching in the mated condition. That's also the case with optical con, which is just LCs inside of a shell, but it's protected by that shell. Those are what you'd see in patch cables inside of your rack. For a trunk cable like optical con, or from location to location, from rack to rack, it's better to use something more ruggedized and reliable, such as optical con or expanded beam. Have you guys run into or encountered any of this stuff in your work? Sounds like you have.
Every day.
Every day.
Okay, cool. Maintaining fiber. It's so scary. It's so scary. It's gonna break. You're gonna bring it and it's not gonna work. It's just different, exactly. There's just a few things you need to know. It's not that big a deal. Regular cleaning before you bring it out and after you are done using it is all you really need to do to keep it in good working order. There's another video that'll explain some of the cleaning processes we recommend. Camplex has a lot of YouTube videos about this as well. But we sell cleaning kits with everything you need to do so, but it really only takes a minute to make sure everything's gonna work, and that's the difference between your show working and your show not working. It's just worth doing.
You know, the thing that I've come to know is that when you're working on a patch panel, a lot of times the instinct is just to do everything, one after the other really, really fast. But with fiber, it makes sense to slow down, take the cap off, put it in, and then do the next one so that you're not leaving the fiber exposed to the elements so you're doing it for the shortest time possible.
Exactly, yeah. All of our tack reels like this, everything comes with dust caps. You should leave them on until you're ready to plug them in. That's just best practice. Do that, you'll be in great shape. Jacketing. Again, most of what we sell, most of what belongs on set or at a live event is a field cable, has some crush resistance, oil resistance, is durable. There are a variety of other jacket types, but at that point you're probably talking about patch cables or install cables. It's another conversation to have, and we're happy to do it, but I don't think it's relevant to this group. What's up?
One thing that I learned a long time ago, fiber code, not the resistor code, completely separate, and it's Max 12.
Oh, the color code?
Yeah.
We do build color-coded breakout assemblies as well. This one's obviously all yellow. The premium version has a thicker furcation tubing, so it's actually crush-proof all the way through and is color-coded. Either way, they correspond to one another. It's pretty simple.
Can you also touch on the UPC versus APC and how to tell the difference? And
Yes, we
adapting?
can. Yeah. So this has come up a bit for Gotham and their selling of Wisycom product. It's just something to be aware of. There is a convention called APC. That stands for angled physical contact, where the fiber itself is cut at an angle. That increases the surface area between the two when they're mated, which results in a slightly less lossy connection. It's a European convention. It's not that common in American gear, but it will not mate or work well if you are using UPC and APC together. UPC is a standard flat cleave. That's what this is. That's what most things are. Bottom line, if you don't know, ask. APC is green. And if you're going to invest in trunk cable or anything to cover a long distance, get UPC cable, because that's what any other equipment is going to use and expect. And the whole idea here is to be able to use this with things other than just RF over fiber, right? Like video, Ethernet, etc. So we don't really sell APC field cables, although we can make them. But it's just a distinction you got to be aware of when speccing this stuff out.
One thing, the reason I think RF over fiber is angled has to do with, it's essentially an analog signal, and so the angled connector, there's something about the reflections being a little bit more attenuated compared to the straight UPC connector.
That sounds about right. I understand it to be a bit less lossy. I don't think that this system would fail if it were built with all UPC connections, but it just isn't. So here we are.
And you can convert between the two.
Yeah.
Do they have
It's just an adapter.
charger adapter? Like
Yep, absolutely. Yeah, so if you were gonna run this over this from here to here, you just have a patch panel on either side of it. This lands into the patch panel on either side, and at the rear of it, or at the back of the patch panel, just I have a few actually over at the table, but
There's no inline connector.
Well, the patch panel is an inline connector, but it's really small. So like when we did this, I keep referencing the Daytona job, but we built in, we had a custom patch panel built, and all it is was, a very tiny little ST connector like that, but built into the panel. So you could conceivably use that isolated. It's very small, and then you've got to deal with the dust caps on both sides. So having a fixed point makes it easier.
yeah.
In Daytona, there was the patch cable, like one connector that physically plugged into the Wizy was angled, and then that went to a UPC into the patch panel.
Yep.
So you can do that as well.
Yeah.
Yep. Mhm.
I can show you. It's just an additional patch cable, and it's totally fine.
Like coax, is there a certain amount of loss with every connection?
Yep.
But
Yeah.
it would be minimal, I would assume.
It would be minimal. It's known as an optical budget. There's optical budget calculators. There's a typical amount of loss per good connection in the imperfect world that these calculators work with. And if you need to do that, if you're really going to be doing a long run, you might want to consider consulting one of those. It sounds like the Wisycom product has a pretty powerful laser in it, so I don't think it's a huge consideration really. Especially not for 3 miles. I think you'd be just fine. But yeah, with every patch, there's a bit of loss.
In that long run you did at Daytona, did you have ST connections on the end of that and then adapt it to an LC to what you had to?
So the short answer is Daytona, what was really nice is that the 3.2 miles of fiber was installed underground by Fox for their coverage, and that all we had to do was tap into their access point. So they had multiple access points around the track, and surprisingly, everything. And there wasn't like a straight run from one point to another. It was going from where we were outside of Pit Road, and then all the way back to this parking lot, which is where they would normally park their video trucks. And then it would go all the way back out to where we had our antennas. So it was really, why it was 3.2 miles, it was not direct. But we were able to tap into it. And that is the beauty of having and I believe, Peter, you would know, you saw the fiber boxes. It was ST, right?
Cross-patched.
Yeah.
I can give, there's a couple of points that we'll touch on later. But one important point, when the stadium fiber person asks you how many strands you need, lie.
So,
Yeah.
And add. Yes, back up. Because it's, especially in a situation where you're not in control. Thank you. When you're not in control, it's dirt. The connectors can be dirt. What are you going to do? You can't clean it. So just move on to the next one.
So the advice is to add, if you're going to a place that has fiber built in, when they ask you how many you need, add. Maybe multiply.
And I think that's the same when interfacing with the video department, like if they have a TAC-12.
Well, I'm gonna say I'm gonna assume that like that, that kind of infrastructure, they were probably running TAC-72 around, and they were probably fusion splicing as needed.
Yeah.
It's a totally different thing when you got a guy that can drop an end anywhere you need one. And that end that you get will be factory fresh, and it will work every time. The problem is that that TAC cable with the ST connectors and those captive caps, because when that thing gets dropped in the dirt, yeah, you cleaned it off to make your patch, but then at the end of your job, you put it back together, you very carefully put the cap back on, and then you made that fiber end filthy. Because there's dirt in the cap that's captive to the thing. So the fiber techs will tell you we hate those kind of caps. We like the ones that just stick on there because it comes from your pocket into the thing. But it's fantastic once you learn how to work with it, but you have to learn.
I'm sorry, I was just going to add, I was going to give the absolute opposite advice because I like the captive thing until what you just said.
Yeah, until the cap's dirty.
And it's Brian, the fiber tech at the marathon that every year bitches about it, so, yeah.
Yeah. So one thing I hope, and if you're gonna get to it, then that's great, but
Yeah.
I wanna know, like, daily care. Like, I wanna know, like, the everyday, like, where we're not fiber techs. I will share one story that is super helpful that everybody who's thinking about fiber should get. There's like a El Cheapo laser device.
EFL?
Yep.
Well, visible fault
Yeah.
locator.
Yeah.
That you know, so that way when they say, I swear it's the brown fiber you should be using, you can say, hang on, I'm gonna put this laser in one end, and if I don't see the laser light at the other end, I know somebody
And
lied.
it's red, you can see it, and you can also point the thing at your palm, and you'll know immediately whether it's got strong light or not, and weak light gets replaced, or not used, or whatever, but, you know, and anybody can be taught to do that, but that's the first line of defense after, of course, cleaning, which is.
Yeah, we did cover cleaning in a different video. You don't have to do it every day, just every day you work. But, I think it's covered in a previous video that we did today. So any questions, feel free to get with me afterwards. We also, Camplex has a lot of videos about this online already.
Yeah.
But it's surmountable and it's worth it. That's what I got for you.
All right. I think we have time for one more question. Anything else? Great. Thank you guys all so much for being here. Thank you, Marcus. Thank you, Lucas. And stay tuned for the live wiring seminar coming up with Laura Cunningham.